Hello students and welcome back to my channel. This is the Toxicology series of videos, and today we're going to continue by taking a look at the persistent organic pollutants and the pesticides. So expect to learn how the dioxins, furans and biphenyls can affect our health, and also how the herbicides and the pesticides can affect our environment and our health. Hi, I'm Tommy. I'm a human nutrition student and researcher at the university. What I do in this type of videos is to synthesize my classes so then I can explain and teach you the best and most valuable information you need to know. So let's begin this video by taking a look at the persistent organic pollutants. So, persistent organic pollutants. What they have in common? Well, persistence, they are chlorinated, and they are resistant. They accumulate very easily because they are fast soluble, so they accumulate in organs. The toxicity? Well, we have 11,000 harmful organochlorines. They are transporters. They are easily dispersible because they are semi-volatile, and they come from the incomplete combustion of organic matter. They are grouped in the dirty dozen and they are part of the Stockholm Convention. This Stockholm Convention has an annex of elimination group, restriction group, and unintentional group of persistent organic pollutants. The most important substances we're going to view are the polychlorinated dioxins and biphenyls, the perfluoroalkyl substances, brominated flame retardants, and chlorinated paraffins. So, the polychlorinated dioxins and biphenyls, we have the dibenzo-paradioxins. These are dioxin-like molecules derived from this one, which indeed are the polychlorinated dibenzofurans and the polychlorinated biphenyls. So, to make it easy, dioxins, dibenzofurans, and biphenyls, also called PCBs. And here we have two concepts, the toxic equivalency factors and the toxic equivalency quantity. These two are used because we often find mixes of these, not isolated substances in the environment. So, to take into account their toxicity, we say that the tetrachlorodibenzoparadioxine is the most toxic one, which has a value of 1, and the other ones have less value because of lower toxicity. So this is the toxic equivalency factors. An example would be a substance that has a TEF of 0.1, which is 10 times lower than the most toxic one. And the toxic equivalency quantity is multiply the equivalency factors with the concentration of that substance in the environment. So to know the toxicity of that substance based also on the quantity of it. The sources can be natural, anthropogenic, organic in complete combustion, of course, and fossil fuel burning. Here we have to follow the 3T regime, which is time, temperature, and turbulency. The toxicokinetics. Well, the food route is the main one. The absorption is correlated with the chlorine, so higher chlorine, lower absorption, lower age, lower absorption, and lower fat tissue, lower absorption. The distribution is together with plasmatic proteins, and the metabolization is continuous but very slow. And the elimination is using the glutathione conjugate. The mechanism of action is a dioxin-like. So it's binding to an AHR cytosol receptor, and it will induce a specific nuclear gene, leading to the chloracne, which is a scaly skin with ulcers, a lower immunity, hepatotoxicity, teratogenic properties, and also a carcinogenic promoter. An environmental occurrence, so how we can find it in the environment? Well, as mixtures of parts per trillion. The tolerable intake levels are 2 picograms per kilogram per week, and the food sources are mainly from animals because of the accumulation in the fat, remember. And the management measures are regulated by the Stockholm Convention. But there is an exception in Latvia, Finland, and Sweden for their products, because they can contain a little bit more dioxins than in other countries. Then we have the perfluoroalkyl substances. These have chemical and thermostability. They have a surface activity, and they are correlated with Teflon, and they are anthropogenic. In the Stockholm Convention, they are in the annex of restriction of use. They come from the diet, from fish, meat, and liver, non-stick pans, important because of the Teflon, also from drinking water, utensils, and packaging. The toxicity, hepatotoxicity, teratogenesis, immunotoxicity, hormonal changes, genotoxic, and carcinogenic. Intake levels. there is a significant drop in reference values. There is a higher risk because of that. Because if we lower the reference values, a lot more people will be diagnosed as exposed to those toxic substances. And the change was from 1500 nanograms of PFOA per kilogram per day to only 8 nanograms of the whole mixture of all perfluoroalkyl substances per kilogram per week. So as you can see, a significant drop in reference values. Then we have the brominated flame retardants. These are anthropogenic substances that basically act as combustion retardants. Polybrominated biphenyls, they can be additives or reactive. The additives are present in the blood and breast milk, and they are highly lipophilic. The reactive are less toxic because they are low lipophilic. There is no evidence of cancer of these substances, and the tolerable intake levels, there are no reference values. So we use the margin of exposure. They are present in the Stockholm Convention, but they are not yet regulated in the European Union. And then we have the chlorinated paraffins. They were used in the industrial area. They act as additives and they are retrophilic, meaning they were used in the past. They appear in animals' fat. They accumulate in fat tissue, remember. They are possible human carcinogens. They are part of the group 2B, so they are highly suspected but not officially carcinogenic. They are present in the Stockholm Convention and maximum limits may appear soon. And then we have pesticides. So the Codex Alimentarius says that they must have a maximum residue limit, and we must follow good agricultural practice to actually make sure that that limit is respected. These maximum residue limits are derived from exposure calculation. The pesticides are environmental and human problems. Again, the One Health concept. And the toxic effects are acute, chronic, or delayed. Delayed means that there is a possible endogenous reintoxication. The mode of use of these pesticides are free, or also called pure, or conjugate. There are rules for application and disposal in place, and the types of pesticides we have are mainly this one right here. The organophosphates, carbamates, and organochlorines. Then we also have the herbicides, fungicides, and rodenticides. The organophosphates are the methyl parathione or the malathione. The uptake is through liquids or aerosols. The distribution through liver and kidney. The exposure occupational, the farmers mainly, but also due to suicide and domestic accident maybe. Mechanism of action, irreversible inhibition of the acetylcholinesterase. Very important, because that will have muscarinic effects from 5 minutes to 3 hours after the exposure, which is indeed parasympathetic-like symptoms, so a lot of lethargy. Then, after 4 hours, nicotinic effects start to appear, which are, for example, the skeletal muscle paralysis. Then, from 24 hours to 96 hours, we have the intermediate syndrome, which is a paralysis of autonomous muscles. And the delayed neurotoxicity is from 7 to 20 days, and it has to do with the sensory motor polyneuropathy, neuronal loss, and learning disabilities. All of these have to do with the acetylcholinesterase, which synthesizes acetylcholine, which is used by our neurons for the synapses. Carbamates, on the other hand, they are similar to the organophosphates, but they have a reversible acetylcholinesterase inhibition. They do not have delayed neurotoxicity because of that reason, and there is a decreased thyroid and hepatic activity here. There are only muscarinic manifestations and no nicotinic manifestations. When alcohol is present, there is a possible shock, and the diagnostic criteria to differentiate between these two is higher levels of acetylcholinesterase in the carbamates compared to the organophosphates. Again, because here the inhibition is irreversible. Then we also have the organochlorines, which is the famous DDT, and the polychlorinated biphenyl-like substances. These are easy to synthesize and apply. They are hydrophobic, liposoluble, persistent, and very high bioaccumulation. The absorption is inhaled, dermal, or digestive. Distribution, gastrointestinal system and liver mainly. Elimination, biliary and renal, but also milk, and this counts as well the animal milks, and feces. The routes, occupational, due to suicide, and domestic accidents. Again, target organs are the brain, there is an increased excitability of axons. This will indeed block the nerve impulses due to the calcium channels. The drug interaction, there is less effects compared to the organophosphates. The acute poisoning will create convulsions, cardiac arrest, dermatitis, digestive and respiratory disorders. And the diagnosis, we have to investigate the presence of pesticides. We have to make an analysis of the liver and kidneys and perform blood and urine tests. So other types of pesticides are the herbicides, for example. These can be either specific, which are selective, so exclusive to plants, or non-specific, by contact. They have a local action and they can harm animals that are around the area. The specific ones are the chlorophenolic compounds. They act as oxidative phosphorylation inhibitors, so they affect the energy production in humans. That's why they have a human toxicity and we have to perform a diuresis. On the other hand, the non-specific is the paraquat. They can enter through the digestive or dermal route and they perform better in alkalinity. The mechanism of action is the reduction of compounds, the protonylation, and the creation of hydrogen peroxide. So it's basically giving electrons and then protons to create free radicals. As you can see, it removes a single oxygen from the O2, which creates a singlet oxygen and indeed free radicals that will damage the cells. Here we have to give renal support, gastric lavage, and absorbance, as well as an artificial clearance if needed. Fungicides. We can differentiate them in contact fungicides and systemic fungicides. The contact fungicides are three mainly. We have the metal-based ones, the sulfur-based ones, the salts, and the benzene nuclei ones. They all stop redox reaction, so reduction and oxidation reactions, and they block the SH, the alkyl groups. And the systemic fungicides, they are the carbamates, the thiocarbamates, the pyrimidines, the thiazidines, and the carboxylases derivatives. And they do block the cell division. And the last but not least, we have the rodenticides. And here again, we have three types. The gaseous ones, the hydrocyanic acid and methyl bromide, which basically are a dense spray that numbs and intoxicates the rodents. Minerals such as arsenic, phosphorus, thallium, barium, and fluorine, and the thallium salts via cutaneous and gastrointestinal routes are absorbed and it replaces potassium, creating an enzyme inhibition most of the times. And then we also have the organic rodenticides. This is, for example, the antivitamin K. They act as anticoagulant, creating internal bleeding. And here you have the dirty dozen of pesticides. Okay, this is it for this video. I hope you understood everything I said. If you didn't, there is a comment section down below. Don't forget to like, subscribe, and turn on the notifications so you get notified every time I upload a new video. If you find value in this, please share it to your friends and family to spread this knowledge to them as well. Thank you so much for watching, and I will see you in the next one, in which we're going to talk about heavy metals. So we'll see you there. Hope you enjoyed. Ciao!